So now let's begin our next section, which is the chi-square. The chi-square is kind of a continuance of what we're doing, but we're going to a different way of measuring statistical significance. And this different way is a chi-square, and the chi-square, which looks like this, right? It's just a x with a superscript of a 2. This means chi-square, right? And the chi-square simply measures dependence. And we need to think of dependence as basically two variables that are interacting with one another. So variable A interacts with variable B. If it does not interact with variable B, there is no interaction. And that means that the two variables are there's independence. If there is interaction, there is dependence. Right? So the best way to think about this is, again, to use an analogy that I use over and over again from the Shakespearean play Othello. If Othello's wife is cheating on him, then we have some action, right? So basically, it is the null hypothesis is basically that there's independence, and the alternative hypothesis is that there is dependence. Hence, if we reject the null, there's dependence. These two variables are having some kind of effect on one another. Now, the problem with chi-square is it is just in a bivariate table. So we have to set up a table, but it simply only measures whether or not there is dependence or independence. That is it, and it's only between two variables. And I'll lead off with the chi-square formula. And the chi-square formula is this, and this is chi-square. It is not x squared. It is the sum of f observed minus f expected squared divided by f expected, right? And the first thing you want to know is, what the heck is f expected, right? So f expected is what we expect our observation to be, right? And there's a formula for it, right? There's row marginal times column marginal, which we'll discuss, divided by n, right? So before we can get to this, we got to figure out this f expected, right? So we'll move on to some examples, but this is the beginning of chi-square.